This video will cover the top flap of section number 2 of your Unit 7 Similarity Flipbook. Top flap of section 2. The title of this flap is Dilation Properties. And the essential question here, if you fill this out, is what are the properties of a dilation? What are the properties of a dilation? Now there's a lot to fill out here. I'm going to have to write fast and small. So hopefully we can fit everything in because there's a lot of properties I want you to know about dilations. So first thing we got to do is let's define some words. Let's first define, what does congruent mean? Congruent means same shape, same size. So you learned this last year. You can use things like translation, reflection, rotation to take a pre-image or an original image or shape and create a duplicate of that image or shape. And it's going to be congruent in every way. It might be moved, it might be flipped, it might be turned, but it is still considered a congruent shape. So same shape, same size. The math symbol looks like this. The math symbol is an equal sign with a squiggly on top to tell us that two things are congruent. The next thing is similar. Similar now, our new word is same shape, different size. So now we're going to learn how to create or how to take a shape and create the same shape as the original pre-image. So the shape's going to look the same, but it's going to be bigger or smaller. So it's going to get reduced or enlarged, but it's still going to look like the original shape. The math symbol for this is just the top of the congruent sign, so just the squiggly line. That means similar. Next definition is dilation. So what is a dilation? A dilation is a change in a pre-image in our original shape which produces a similar image. So change in a pre-image which produces a similar copy or a similar image. Notice it's no longer congruent. So similar means same shape but different size, and we have two types of dilations. We have a reduction. That's going to take a pre-image and make it smaller. And we have an enlargement. It's going to take a pre-image and make it bigger. Next definition is scale factor. Scale factor. The scale factor is a ratio. We've learned what a ratio is, just a fraction. A ratio which describes a dilation. If the ratio or the scale factor is between 0 and 1, it means we're going to reduce the pre-image and make it smaller. If it's greater than 1, it means we're going to enlarge the pre-image. Our copy is going to be larger than the original. And if scale factor is exactly 1, actually a scale factor of 1 just creates a congruent image. So a scale factor of 1 doesn't make it bigger, doesn't make it smaller. Stays the same size, and it's already the same shape. So it's a congruent image. Now something very important for you to remember here. When you write a scale factor, you're always going to have the measurement that comes from the image or the copy on top and the measurement that comes from the pre-image or the original shape on the bottom. So I want to make sure you note here, okay, the numerator is from the image. Remember, the image is our copy. The denominator comes from, so numerator, let's put a colon here. The numerator is from the image. The denominator is from, make a little more space here, is from the corresponding It's going to be very unreal. It's going to be tough in this video class because I've got to fit a lot in a very small space. It's from the corresponding side of the pre-image of the pre-image, which is our original. So the image measurement will always be on the top of our scale factor, and the corresponding side of our pre-image, the one that's the same side as our image side, is going to be in the denominator. If you don't do it this way, you're going to end up with wrong scale factors. All right, let's start going through our properties of dilation. That's wrong. Let's see if I can get this back. All right, so there's a diagram. There's a diagram over here on the right hand side of the page. Let's do a couple things here. Class, you're going to pause this video, and I want you to carefully take a straight edge, and I want you to carefully draw 3 lines, and they're each going to go through corresponding vertices. And you do it the same way you see on this paper. Carefully draw straight lines. If you do it careful, you're going to end up with an intersection of all 3 lines somewhere over here. First thing I'm going to show you is if 2 shapes are a dilation, if one is a dilation of the other, then you should be able to take a straight edge and draw through the corresponding vertices, and you're going to end up all of them intersecting at one exact point. And this point is called the center of dilation. The center of dilation. Let's label that as D for this example. So there's a D. All right, let's pretend or assume that this first shape is our pre-image. It doesn't have to be. This could be our pre-image. This could be a reduction. Let's assume this is our pre-image. So I'm going to label it pre-image. And remember, our pre-image is our original. It's our original shape. Okay, if that's our original, that means that this one must be the image, which we could also call our copy. That's what we're changing our original into. So this one is going to be our copy. Let me fix that. Okay, and let's label some vertices here. I'm going to label this as A, and this as B, and this as C. And if we're going to label our copy, we can label these with prime notation so we know which point goes to which point. You don't have to do that, but it sure is a nice way to keep track of which point corresponds to which point. Okay, let's take a look at some other properties of dilations now. The first thing we will notice if we check these 2 shapes out, if this were a true dilation, that we will be able to know that the corresponding if I could write that correct, the corresponding angles are congruent. You have a dilation of one shape to another, then you know that the corresponding angles must be congruent. So in this case, angle A is going to be congruent to angle A prime. Angle B is going to be congruent to angle B prime. And angle C is going to be congruent to angle C prime. So, dilations, class, they do not change angle measures. The angle measures will be congruent if you have a dilation. That's what keeps the same shape between 2 shapes if they're dilations of each other. They are going to have same angles because the shape is going to be the same. Okay, what's another property of dilation? Here's the next one. Corresponding And hopefully you're listening to the video and not just writing, because if you're just writing, you're going to have a hard time reading my writing. Corresponding sides are not congruent anymore because now it's getting bigger. They are proportional, and we've learned about proportions already. That means they're going to have the same scale factor or the same ratio if we compare them to each other. So corresponding sides are proportional. That means if this is a dilation, that means that side AB on our pre-image divided by side A prime B prime on our image, that ratio is going to be exactly the same as side BC to side B prime C prime. And that's going to be the exact same ratio as side CA on our pre-image to side C prime A prime. This is a way to prove that two shapes are similar. Write the ratios of the corresponding sides. AB corresponds to A prime B prime. BC corresponds to B prime C prime. Those are all going to be equal ratios. They are going to be proportional. So that's another property of a dilation. Let's do another one. Running out of time here, so I got to be real fast. Okay, the next thing is the distances from the center of dilation, I'll just do COD, from the center of dilation to the vertices are also proportional. Pretty amazing property of a dilation. So that means that the distance from D to A divided by the distance from D to A prime is equal to the distance from D to B divided by D to B prime, and that's actually equal to the distance from D to C divided by the distance from D to C prime. So the distances from the center of dilation to each of these two shapes, the image and the pre-image, are proportional. Okay, next thing we can write on here is scale factor. If you have a dilation, that means you're going to have a scale factor that describes the differences between the sides of the pre-image and the image. Remember our scale factor back here, we talked about it as image over pre-image. That means the scale factor is always going to be a measure of a side from the image over a measure of the corresponding side of the pre-image. Let's take a look. Let's pretend, let's just say that AB is equal to 3, and let's say that A prime B prime is equal to 6. Then our scale factor is going to be the side length of the image, which is AB, A prime B prime, which is 6, over the corresponding side of our pre-image, which is 3. And that means the scale factor of this particular example would be 2 to 1. We could also write that as 2:1, or we could also write that as 2 to 1. Okay? Now you can use any corresponding side to find your scale factor, and you should write that in here. You can use any corresponding side to find the scale factor. You didn't have to just pick AB and A prime B prime. I could have picked any two corresponding sides. Okay? Also, one more thing I want you to note here is, take a look at this image and pre-image. Corresponding sides are also parallel. Let's write that up here. That's another one I wanted to add. Corresponding sides are parallel. So, if you have a dilation, you guaranteed that AB is parallel to A prime B prime, and every other corresponding side is parallel